Welcome to Spring LIB.
31.46, we have an alternating EMF source with a variable frequency, and we're connected to a series resistor-capacitor circuit. So the first thing we would like to do is draw a phasor diagram, and then we're going to have several more questions essentially based off of that. So the first part is just to sketch the phasor diagram. So let's say we have the voltage across the capacitor here. We'll have the voltage across the resistor here. And then the applied EMF will be here, and its length will be the magnitude of that. And we have our phase angle between the capacitor and the EMF here. So this is, what it looks like. So now we want to find the driving frequency such that the two phasors have the same length, which is to say V sub r equals V sub c, or this is the current times the resistance, this is the current times the reactance. So we want the resistance to be equal to the reactance of the capacitor. The reactance is 1 over we have an F, so let's just do it in frequency to begin with. 1 over 2 pi F times C. So we have F is going to be 1 over 2 pi RC. Which is 159 hertz. Now for part C, for C, D, and E, we're at this driving frequency. For C, we want the phase angle in degrees. So this is the arctangent. Of negative VC over VR. These are equal. So we don't even have to put this into a calculator. Assuming you remember that if the x and y components of a vector or whatever are equal, that its angle with the axes is 45 degrees. And then tangent being an odd function means that the result is odd if the argument, or the result is negative if the argument of this is negative. Part D, we want the angular speed at which the phasors rotate. So everything in a phasor diagram rotates at just the driving frequency, assuming there's only one frequency going on in the problem, which is true of most of all of these, is just there's some sinusoidal driving being applied. Then this omega is just the one that corresponds to the frequency over here, so it's just 1 over RC, which is 1000 radians per second. And now we want the current amplitude. So this will be the driving voltage amplitude divided by the impedance. The impedance is R squared plus XC squared, which we already know is equal to R squared. So this will just be 2R squared. So this is 170 milliamps.